Okay, what we're going to discuss in this tutorial is horizontal versus oblique asymptotes, and then how to find a horizontal asymptote and how to find an oblique asymptote. By definition, horizontal and oblique asymptotes tell us how a graph is behaving as the x values approach either positive or negative infinity. In other words, as you go way out to the left and as you go way out to the right. Now, we cannot have both horizontal and oblique asymptotes, and here's why. If I were to tell you that a graph is rising as we go out to the right, let's say it's rising as I'm going to positive infinity, and then I also said it's going in a horizontal direction as well, it would no longer be a function. If I would do a quick vertical line test, I could see that this is not a function. So a graph either has to be rising, falling, or going flat as we approach positive and negative infinity. It can't be doing more than one of those things. So let me give you one more example. If I told you that the graph was going horizontally as I approach positive infinity, but then I also said in the same sentence that it was falling as I was going out to positive infinity, again, it's not a function anymore. Vertical line test, not a function. So it can only do one of those two things. It either has to be flattening out in a horizontal way, it has to be rising in a positive direction, or it has to be falling in a negative direction. Okay, now let's get into how to actually find these. The first scenario we're going to go over is, what if the degrees are the same? So in this case, I see that my degree on the top is 2, my degree on the bottom is also 2. When this happens, the horizontal asymptote is going to be the ratio of the leading coefficients. My leading coefficient on the top is 2. My leading coefficient on the bottom is 1. Therefore, my horizontal asymptote is 2 over 1, or 2. And that's it. Done. So I will draw a dotted line at y equals 2 for my asymptote. The second scenario is if the degree is larger on the bottom. In this case, my degree on the top is 2. My degree on the bottom is 3. When this happens, the horizontal asymptote will always be y equals 0. Always. So again, when the degree is larger on the bottom, it will always be y equals 0. The third scenario is if the degree is larger on the top. In this case, we have a 2 on the top and a degree of 1 on the bottom. When this happens, this is when we have an oblique asymptote. It's not a horizontal asymptote. So how do we find it? I'm going to call this the OA, the oblique asymptote. To find the oblique asymptote, I'm going to use synthetic division, which you've already learned about. So I take my factor x minus 4, set it equal to 0, and I get 4. That's where that's coming from. I'll line up my coefficients, 2, 1, and negative 5. Now, I'm going to x out this remainder because the remainder does not matter when I'm finding an oblique asymptote. So I drop down the 2, and I get 8, and this gives me 9. So therefore, in this case, my oblique asymptote is the line y equals 2x plus 9. So I would graph that line using a dotted line, and that's my oblique asymptote. Now, the reason I dropped off the remainder is because we're never actually going to touch the oblique asymptote. And since the remainder is such a small addition to that line, if I'm never going to touch that line anyway, then the remainder really isn't going to matter. That's why I can ignore the remainder. So let's recap those three again. When the degrees are the same, we take the ratio of the leading coefficients. The ratio of the leading coefficients. That's it. When the degree is higher on the bottom, we always have y equals 0 for the horizontal asymptote. And when the degree is larger on the top, we're always going to have an oblique asymptote, and